Tweaking Celery for high performance. I'm trying to send ~400 HTTP GET requests and collect the results. I'm running from Django. My solution was to use Celery with Gevent. To start the Celery tasks, I call get_reports. I use for workers. And I use rabbitmq as the broker. And although it works much faster than running the requests sequentially, 400 requests took 23 seconds, I noticed that most of that time was overhead from Celery itself, i.e. if I changed get_report_task like this. This whole operation took 19 seconds. That means that I spend 19 seconds only on sending all the tasks to Celery and getting the results back. The queuing rate of messages to rabbitmq seems to be bound to 28 messages per sec, and I think that this is my bottleneck. I'm running on a Win8 machine if that matters. Some of the things I've tried. Using Redis as broker. Using Redis as results backend. Tweaking with those settings. Broker_pool_limit equals 500. Celery_prefetch_multiplier equals 0. Celery_max_tasks_per_child equals 100. Celery_ax_late equals false. Celery_disable_rate_limits equals true. I'm looking for any suggestions that will help speed things up.
How about using Twisted instead? You can reach for much simpler application structure. You can send all 400 requests from the Django process at once and wait for all of them to finish. This works simultaneously because Twisted sets the socket into non-blocking mode and only reads the data when it's available. I had a similar problem a while ago, and I've developed a nice bridge between Twisted and Django. I'm running it in production environment for almost a year now. You can find it here, this URL. In simple words, it has the main application thread running the main Twisted reactor loop, and the Django view results is delegated to a thread. It uses a special thread pool, which exposes methods to interact with reactor and use its asynchronous capabilities. If you use it, your code would look like this. This still is something you can optimize a lot here. Every call to get page would create a separate TCP connection and close it when it's done. This is as optimal as it can be, providing that each of your 400 requests is sent to a different host. If this is not the case, you can use a HTTP connection pool, which uses persistent connections and HTTP pipelining. You instantiate it like this. Then a single request is performed like this. This goes instead the get page call.
Are you really running on Windows 8 without a virtual machine? I did the following simple test on 2-core MacBook 8GB RAM running OS X 10.7.
Well, it turns out I had two separate issues. First off, the task was a member method. After extracting it out of the class, the time went down to about 12 seconds. I can only assume it has something to do with the pickling of self. The second thing was the fact that it ran on Windows. After running it on my Linux machine, the runtime was less than 2 seconds. Guess Windows just isn't cut for high performance.
If you want to support the channel, please consider liking and subscribe.